Good morning, student. Welcome to the second class of chemistry. Today we are going to discuss about the state of matter. Generally, we know that there is three state of matter: solid, liquid, and gases. There are three state of matter. Generally, there are three state of matter. Those are solid, liquid, and gases. Except those, there are other state also have. Those are Bose-Einstein condensed state and plasma state. Bose-Einstein condensed state and plasma state. But here we will only discuss about the solid state, liquid state, and the gaseous state. At first, come to the point: solid state. There are many solid compound in our surroundings. For example, a bricks, a book, a pen, a sponge, a rubber band. Those all are the solid compound. See here, some given all the above are solids which I have told. We can observe that all those have a definite shape, distinct boundaries, and fixed volume. That is, have negligible compressibility. Solid have a tendency to maintain their shape when subjected to outside force. Solid may break. Oh. Solid may break under force, but it difficult to change their shape, so they are rigid. So those are the general properties of the solid. Those are all are the general properties of the solid. Now come to the point. Consider the following: what about a rubber band? Can it change its shape on stretching? Is it a solid? Then the question is, what about sugar and salt? When kept in different jar, those take the shape of the jar. Are they solid? What about a sponge? It is a solid, yet we able to compress it. Why? So come to the first question answer. A rubber band changes its shape under force and regain the same shape when the force is moved. If excess force is applied, it breaks. So we know that a rubber band can change its shape when we apply force. A rubber band can change its shape when we apply force. Clear? But when we remove the force, then again it gain its original shape, and when we apply excess force, then it breaks. So from this we can conclude that a rubber band is a solid compound. Then come to the point: the sugar and the salt. When we keep the sugar and the salt in a jar, it acquires that jar's shape. So can we tell them as solid? Yes, obviously we can tell them as a solid. How? Because the shape of the each individual sugar of the salt crystal remain fixed. Whether we take it in our hand, put in a plate or in a jar. That means the overall shape change, but the individual shape of the each crystal of the sugar or the salt remain unchanged. That's why it's a solid. The sponge, we can change the shape of the sponge by applying pressure. That means it is easily compressible. Why it is easily compressible? Because sponge contain very small or tiny holes, and those all contain air, and if we apply those pressure, then air is removed and it compress. That's why we can compress it. So although we can compress a sponge, but it's a solid substance. It's a solid substance. Clear? Acha. Now come to the point, the liquid state. Now come to the point, the liquid state. In case of liquid state, we observe that liquid have no fixed shape but have a fixed volume. They take up the shape of the container in which they are kept. Liquid flow and change shape, so they are not rigid but can be fluid. So from here we can tell that the liquid have a no fixed shape, but they have a fixed volume. So when we keep any container, it acquires that container shape, and this as the liquid can flow, that's why they known as the fluid. As the liquid can flow, they known as the fluid. Acha. Then counterpoint: the gases from the atmosphere diffuse and dissolve in water. Those gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animal and the plant. Yes, this one I have discussed in my previous class, that the as the liquid and the gases are fluid, that means they can flow from one place to another place. So the gases like oxygen and carbon dioxide can dissolve in water, which is essential for the survival of aquatic animals and the plant. Then come all the living creatures need to breathe for survival. The aquatic animal can breathe underwater due to the presence of dissolved oxygen in water. Thus, we may conclude that solid, liquid, and gases can diffuse into liquid. The rate of diffusion of liquid is higher than that of solid. This is due to the fact that in the liquid state, particles move freely and have greater space between each other as compared to particle in the solid state. Yes, as we know that liquid has only the fixed volume, no fixed shape, this concludes that the particle in the liquid are much far away from each other than that of solid state. That's why the liquid also diffuse much faster than the solid. Clear everyone? আচ্ছা, now come to the point the gaseous state. Gaseous state এখানে দেখো, Acha. We have observed that gas are highly compressible as compared to the solid and liquid. The liquefied petroleum gas cylinder that we get in our home for cooking or oxygen supplied to hospital in cylinder is compressed gas. When we get the CNG or LPG, they are in the liquid state. When we get the LPG or CNG, they are in the liquid state because they are highly compressed. They are highly compressed. That's why they in the liquid state. And from here you have to learn that what is the full form of the LPG, what is the full form of the CNG. LPG is used for the household cooking and CNG is used for the vehicles fuel. Clear? Acha. From this we can conclude that the gas have high compressibility. That's why we can convert it into liquid and transport from one place to another place. Okay. Again, another point. We come to know of what is being cooked in the kitchen without even entering there by the smell that reaches our nostril. How how does this smell reaches us? The particle of the aroma of food mixed with the particle of air spread from the kitchen reaches us and even further away. The smell of the hot cooked food reaches us in a second. Compare this with the rate of diffusion of solid and liquid. Due to high speed of particle and large space uh, between them, gas show the property of diffusing very fast into the other. So from here we can tell that the gaseous particle diffuse very fast from one place to another place. So this happens due to the high kinetic energy of the gaseous molecule. So, that's why we can take the smell of the food cooked in the kitchen from a large distance. Clear? Achha. Another point, in the gaseous state, the particle move about randomly at a high speed. Due to this random movement, the particle hit each other and also wall of the container. The pressure exerted by the gas is because of this force exerted by the gas particle per unit area on the wall of the container. Clear this one? So, how does a gas give pressure? How does a gas give pressure? From here this portion you have to memorize properly. Clear? This portion you have to memorize properly. Acha. Those question you have to write answer in your home. This is your homework. Write answer here. Okay, clear? Acha, next point, come to the point, can matter changes its state? So we know that in our nature the water exists in the three state: solid state as ice, liquid state as familiar water, and the gaseous state as we know it's water vapor. So we have to know here that how can that matter changes their state. Here we have done an experiment. We have taken some ice cube on a beaker. We have taken a burner and a thermometer is fixed with a iron stand, and we are slowly providing heat to here. We are slowly providing heat to here, and with increase in the heat or with increasing time, we can see that the ice continuously getting melting, and the temperature also rising up. And after some time we see that the water converted into vapor state. The water converted into vapor state and temperature also become very high. So we can tell that by applying temperature we can change the state of matter. Here is a detailed explanation given here. Let's read. On increasing the temperature of solid, the kinetic energy of the particle increases. Due to the increase in kinetic energy, the particles start vibrating with a greater speed. The energy supplied by heat overcome the force of attraction between the particle. The particle leave their fixed position and start move more freely. A state is reached when the solid melt and is converted into liquid. The minimum temperature at which a solid melt to be a liquid at atmospheric pressure is called its melting point. So what happens when you are providing temperature or providing heat to a solid substance? After providing heat to the solid substance, the solid molecules started vibrating, and they want to acquire more space. They want to acquire more space between them, and that's why the particle moves far away from each other. The particle moves far away from each other, and once state came, the solid start melting and convert into liquid state, and the temperature at which a solid melt to become a liquid at atmospheric pressure is called its melting point. So what is the melting point? From here you have to memorize. And what is the cause of melting of the solid when we are providing heat? This is the answer. What is the cause of the melting of solid? This is the answer here. Okay. Achha, here one is point is given. This is important. The melting point of solid is an indication of the strength of the force of attraction between the particle. The melting point of a solid is an indication of the strength of the force of attraction between the particle. This one you should remember. Okay, clear? Achha. The melting point of ice is 273.15 Kelvin. The process of melting, that is change of solid state into liquid state, is also known as fusion. Clear? So the changing of the solid into liquid is known as the fusion. When a solid melts, its temperature remains the same. So where does the heat energy go? So when you are providing the heat energy, their heat energy is applied to overcome the intermolecular force between them, between the molecule. The heat energy is applied to overcome the intermolecular force between them. Okay, clear? Acha, here is given by overcoming the force of attraction between them. Okay, clear? This is Acha, let's read. As this heat energy is absorbed by the ice without showing any rise in temperature, it is considered that it gets hidden into the content of the beaker and is known as the latent heat. The word latent means the hidden. The amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. This point is very much important. Latent heat. What is the latent heat? So what is the latent heat? Latent heat does not change the temperature. Latent heat only change the state. Latent heat does not change the temperature. It only changes the state of matter without changing temperature and at a specific atmospheric temperature. The definition is given. The amount of heat energy is required to change 1 kg of solid into liquid at atmospheric pressure as at its melting point is known as the latent heat of fusion. So the particle in water at 0 degree centigrade have more energy as compared to particle in ice at the same temperature. Why? Because we have to provide energy so that ice particle convert into water particle. So after gaining energy, the ice particle converted into water particle. That's why the water molecule have more energy than the ice energy. Okay, clear? Simply when we apply heat energy to water, particles start moving even faster. Okay, at a certain temperature a point is reached when the particle have enough energy to break the free from the force of attraction of each other. At this temperature the liquid start changing into gas. The temperature at which a liquid start boiling at atmospheric pressure is known as its boiling point. So what is the boiling point? From here to read. The temperature at which a liquid start boiling at atmospheric pressure is known as its boiling point. Clear? Acha. Boiling is a bulk phenomenon. The particle from the bulk of the liquid gain enough energy to change into the vapor state. Clear? For water, this temperature is 373 Kelvin. That means 100 degrees centigrade. 100 degrees centigrade is equal to 273 plus 100 is equal to 373 Kelvin. Okay? Clear? Acha. So the definition. So similarly, the latent heat of fusion, there is also a latent heat of vaporization. What is the latent heat of vaporization? The heat energy required to convert 1 kg liquid into 1 kg vapor without changing its temperature. Without changing its temperature, it's known as the latent heat of vaporization. Latent heat of vaporization. Clear? So in case of latent vaporization also there will be no change in temperature, only change in the state. So what I have told, the latent heat only change the state of the matter, not the temperature. Okay, clear? Here is a table, it's given. So that's all for today. Do practice more and more in your home. Goodbye.